Bismillahirrahmanirrahim. Assalamu alaikum students. I am Sabir Hasnain, your science subject teacher. As we discussed in previous videos about reactions of metals with acid, with water, with air and oxygen. Now in this video lecture we'll further discuss about ores and metals from the surface of earth and how we can extract metals from their ores. So metals from the earth, actually we know very well all the metals exist inside the earth crust. Some metals, when we dig out from the earth crust, they can be in pure form or they can be in impure form. It means metals from the earth crust are actually in two forms. Either they are pure, those are called pure form of metals, or impure, the impure form of the metals, which in other words some impurity is mixed in those metals. So what is the pure form of metal? So the pure metals, actually metals in which there is no impurities mixed, those are called pure metals. They can be found deep inside the rocks. The question is why these are in pure form inside the earth crust. The reason is very simple, because these metals are at the bottom of the reactivity series. If you people remember the previous videos, in those previous videos when we discussed the reactivity series, silver, gold and platinum, they have no reaction with air, oxygen, with water or with dilute acid. So that's why they will remain in their pure form. So on the left side of the picture we have gold, and on the right side of the picture we have silver. So gold, silver and platinum, they are actually the pure form of the metals. So impure form of the metals, all those metals which are found in the rocks in the form of a compound are impure metals. In other words, some impurity is mixed with them. These are also known as ores. This is actually because these metals are reactive with oxygen, with sulfur, and these metals are at the top of the reactivity series. For example, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper. These are above in the reactivity series in order wise. So that's why they are more reactive, and when they are reactive they made their oxides of the metals and sulfides of the metals. That's why they are impure. So how we can dig out these ores from the ground? So from there we can extract metals from their ores. Few examples of those ores are hematite. Hematite is actually the iron ore, which is on the left side of the picture, and bauxite is the aluminium ore, which is on the right side of the picture. Now question is this: how we can extract metals from their ores? Actually there are two stages. From those two stages we can extract the metals from their ores. In the first stage, when metallic compound materials are actually separated from the rocks and other waste materials. Metallic compound materials are separated from the rocks and other waste material. So firstly we separate the metallic compound material and from the rock, and other waste material will be separated. What will be the second step? So the second step, from that metallic compound, the metal has to be extracted from that metallic compound, and we can extract the metal in this way. Now, what are the methods through which we can extract those ores, through which we can get the metals in pure form through their compounds? Either they are in oxide or either they are in sulfides. So metals which are most reactive and high in reactivity series, for example aluminium, they can be extracted by using electrolysis. Later on in this video we'll discuss what is electrolysis. So aluminium is the example through which can be extracted by using electrolysis process. What is the second method? Metals which are actually less reactive or lower in the reactivity series. For example iron, if you remember the series, iron is less reactive, so that can be separated from their ores by using smelting process. Iron, as I told you, iron can be extracted by using smelting process. So now, what is electrolysis? Electrolysis is actually a chemical decomposition of a compound produced by an electrical current through a solution or a liquid. Look at the figure. We have a cell. This cell is actually a steel cell. Inside that we have an ore. As you know, electrolysis is used for high reactive metals. So we use aluminium ore, which is dissolving in the solvent at around 950 centigrade. So when we put them, that can be separated through electrolysis process. And the black figure is graphite rods. These graphite rods are actually electrodes. At the top we have also electrodes. Those are graphite electrodes. One is positive, another one is negative. Positive contains the positive charge, or it is positive end of the battery, connected to the positive end of the battery, and negative one is connected to the negative end of the battery or source. So when the reaction will occur, at that time at the bottom we'll get the molten aluminium form, which is actually in pure state. And this is how we can extract aluminium through electrolysis process. So that's why the apparatus. So what is the conclusion? The apparatus consists of a cell or a jar. In the figure you know very well. So the liquid and solution which is used for electrolysis is called electrolytic solution. And as I told you, there are two plates. One is positive, another one is negative, used in electrolytic cell. These plates are called electrodes. Positive electrode is called anode, negative electrode is called cathode. So a pure metal is deposited on these electrodes. These electrodes in the figure, look at again. At the bottom we have the negative electrode. So aluminium, we get the aluminium at the bottom. So these electrodes are also used for the flow of current. Now the last point, extracting by smelting. So this is the second method. As I told you earlier, smelting, we do the smelting process for those elements which are metals, oxide, which are low in reactivity series, for example iron. So in this case, or in this process, we put the oxides, iron oxide or iron ore, from the top of the blast furnace. In the given figure, this is actually the blast furnace. So in this process, in which oxides are removed from the metal in the blast furnace, called smelting. So first step is, iron oxide is first separated from its impurities in the hematite. Then we put it into the blast furnace along with the carbon at high temperature. Why we use carbon? That's very simple. As I told you, iron is in the form of oxides. So the oxygen present inside the iron reacts with the carbon and it forms carbon dioxide, and that after during the reaction carbon dioxide gas will move in upward direction. So hot gases from the blast furnace comes out from the left side and the right side of the figure. So that's why we use carbon at high temperature, and oxygen will remove from the iron. So definitely when oxygen is removed from the iron, we get the pure form of the iron, and this is how we get a pure form of any metal. These are the two famous methods through which we can find out, we can extract metals in their pure form from their ores. Thank you very much.